In this lesson, we're going to examine some lines that appear in geometry. Call them geometric lines. There are three types. One of them we've already done, median, so we'll quickly review that. So look at the first example here. Given a triangle with vertices A, B, and C, determine the equation of the median from A. So if we draw that out, A is 0 and 2, B is 6 and 8, and C is 4 and negative 2. So triangle, I want to find the median. In particular, the median from A. So I know where to start. That's my starting point, A. But where do I end? It ends at the opposite midpoint. So step one, I need the midpoint of BC, so I know where to draw my line. So BC, midpoint. We'll add them together. We'll divide by 2. Which will give us 10 over 2 and 6 over 2. In other words, 5, 3. Okay, 5 and 3, right about there. There's my midpoint. There's my line. Okay, I'm ready to go. I want to find the equation of that red line. What do I need? I need a slope. So I need the slope from the start at A, and ended at B, or midpoint B, C, sorry. So my slope will be 3 minus 2, and 5 minus 0. So I get 1/5. Now, if you want to work with decimals, you can. 1/5 comes out to a nice decimal. Nothing wrong with that. I am doing fractions, but you can use decimals if you want to. Okay, what do we got? We got ourselves part of the equation. You got the m part. I don't have the b. To get b, I need to use a point. Any point that I know that's on this line. I know 2 of them. I'm going to use a, x, and y as my point. Y is 2, x is 0. Oh, 1/5 times 0 is just 0. So in other words, b is 2. Or if you actually stop and think about it, isn't that a y-intercept? Can't you see it right in the picture? It's right there. There's your y-intercept. So our equation is, therefore, y equals 1/5 x plus 2. And we've done a lot of practice on medians, so hopefully we're pretty good at them by now. We're going to look at some new ones today. So idea number 1, new idea, an altitude. An altitude, in geometry, this is the line from the vertex of a triangle to the opposite side where it forms a 90-degree angle. We know this as the height of a triangle. If you look at that red line, it goes from up here at vertex A straight down the other side of right angle. Right angle. Isn't that your height? But there's more than one height in a triangle, just depending on your point of view. If I did this one and called this B, well, to the opposite side there's a right angle, that would be the height also. And now those heights are not the same size because they're drawn in different spots. But the idea of area, base times height divided by 2, well, you have a different, this would be a different base compared to this being the different base, right, depending on the situation you have. We're not going to worry about area today. We're going to be worried about finding the equation of the line that represents the height, or in other words, the altitude. So to do this, 3 steps. So we'll go back again. Just take a look at this picture here. Erase some stuff. Okay, in the picture, I want to find this line, the red line, from here to here. I know where it starts. It starts at point A. But unfortunately, I don't know where it ends. I only know how it ends. It ends at a right angle. In other words, it ends at a perpendicular angle. So what I need to do first is I need to find the slope of the opposite side. Okay, so if this was B and C, I'm going to find its slope first. Because I know that slope's related to my slope. My slope is perpendicular. So I can find the perpendicular, negative reciprocal, pretty quick. And once I know that, I've got a slope. All I need is a y-intercept. I need a point. And I have a point. I have the point I started from, this point up here. So we're going to try some examples and get the hang of this. I'm going to do the first one for you guys, and then you guys try the second one yourselves. So, given the triangle with vertices A, B, and C, determine the equation of the altitude from A and then from altitude from C. So we'll draw it out. It's actually the same triangle from the first one, in case you didn't notice that. Okay, so 0, 2, and we had 6, 8 was up here, and C, 4, and negative 2 is down here. And make my triangle. Okay, so I'm going to start off with the altitude from A. So I know it starts at A. I know it's going to meet the opposite side at a right angle. So, back to our picture here. Yeah, so it starts at A. And I know it meets at a right angle. So you're going to have to make a judgment call here. You're going to have to draw this and say, okay, that's a right angle. That's where my line goes. I want the equation of this line. To do that, step one, I got to figure out the slope of the opposite side. So the slope of BC. So BC will be negative 2 minus 8 and 4 minus 6, which is negative 10, and negative 2, which is 5. But that's not my slope. My slope is the negative reciprocal, the perpendicular to that, because these lines make the perpendicular. So my slope, I got to flip it over, so 1 over 5 now, and change the sign. That's step number 2. Step number 3, you got to find the equation. Well, I know the slope already, mx plus b. All I need is a b, a point. I need a point, and I have a point. And if you remember from the previous example, if you stop and think this is actually a y-intercept, right? The y-intercept is 2. You can see it there. Okay. Or you could fill the point in. That works totally fine too. Okay. If I fill the point in, I get negative 1/5 times 0, which we know is just 0. So in other words, b is 2. Okay, so the equation of this altitude, this height, is negative 1/5 x plus 2. Okay. You guys are going to try the next one. Okay. You're going to find me the altitude from C. Let's give that a try. So pause it, you try it. So C, I know it starts here. I know it has to hit the other side at a right angle. It's going to have to go somewhere like this, it looks like to me. Yeah, it's kind of a right angle. What do I need first? I need, step 1, the slope of AB, because that's where it's going, right? It's going to go perpendicular to that AB there. AB is 8 minus 2 and 6 minus 0, which is 6 over 6, which is 1. Okay. Step 2, I know it's actually perpendicular. So I'm going to find a perpendicular slope to 1. So if I flip it over, I get 1, because 1 over 1 is still 1 over 1, but I need the opposite sign. All right, step 3, I need the equation. So I know the slope. I'm going to find B using a point. The only point I know for sure is C. It looks like it's pretty close to A, but I don't know if it goes through A or not. So I can't use that. I have to use the point where I started from. It's the only point I know for sure. So negative 2 for Y and 4 for X. That's what we're going to solve. Negative 2 equals negative 4 plus B. Negative 2 plus 4 is B. B is 2. Therefore, Y equals mx plus B. And it turns out that it actually does go through A. In fact, that means that this triangle, not that we need to know, but this triangle is a right angle triangle. There's a right angle in this corner over here. Okay, and hopefully you got that one yourself. That's an altitude. That's all we can really do with altitude. Find the height on their equations. So idea number 2 for today, perpendicular bisector. This one sounds a little more confusing, but you've actually done this already. This is the idea about we have a garbage dump between 2 towns. It's the equal line between 2 points. Okay? In geometry, we could define this as the line that divides another line in half. So it bisects. And it does it at a right angle. And that's why it's called perpendicular. So perpendicular bisector. And what's really handy about this line isn't the lines themselves, it's where the lines meet. Because the point where 2 or more perpendicular bisectors meet, which is called the circumcenter, is important. Because when you draw a circle that just touches all the vertices of the triangle, okay, where the circumcenter meet turns out to be the exact center of that circle. This distance and this distance and this distance are all the same. They're the radius. I'm not going to worry about circumcenters today, but it's a really useful idea we will do down the road. My objective today is just to find those bisectors. So let's go back and look at the bisectors for a second. And look at the red one here. This bisector is the midpoint between 2 things, A and B. So I can find that. That's pretty easy. It's also perpendicular to the slope of A and B. So the three things I need to find in this case are, number one, AB. Find its slope. Because if you know it, you can do the perpendicular. And if you know those two things, and you can find the midpoint, you can make yourself a line. Okay? We're going to try one last example here. Different triangle this time. So given the triangle of vertices A, B, and C, let's draw that out. A is negative 2 and 2. B is 4 and 8, way up here. And C is 2 and negative 2. I want to find the perpendicular bisector of AB. In other words, you can go through the middle of AB. So step one, let's find the middle of AB. All right, middle of AB, that's somewhere in, I can't see it, I gotta find it first. So let's do midpoint. Negative 2 plus 4 over 2, and 2 plus 8 over 2 gives us 2 over 2, and 10 over 2, which is 1, 5. Okay, I know where it goes. It's right here. And I know it's going to go through there at a perpendicular. It's going to look like this. Right angle. Oh, right angle. Right angle to AB. So let's find the slope of AB. Slope of AB is 8 minus 2 over 4 minus negative 2. That gives me 6 over 6, which is 1. But that's AB. I want its perpendicular. So I need to do the reciprocal. Flip it over and change the sign. When we flip 1, you get 1. You get negative. So that was step 2. And step 3, if you will. Step 4, let's find the equation. We know our slope is negative 1x plus something. I need a point, an x and a y, that I know is on this line. There's only one point that I know, the midpoint. It's the only point that I know for sure is on this line. And I know the point there is x, 1, y is 5. So y is 5, x is 1. Let's solve for b. I get 5 plus 1 is b. So in other words, b is 6. So the equation of that perpendicular bisector is negative 1x plus 6. So this one's slightly more intense because there's more things to find. But to be honest, this is exactly what you did when you had town A, town B, and we had to put a garbage dump down the middle. That's what we were doing. I just didn't call it that. But it's what you've done already. All right, you try the last one here. Find me the perpendicular bisector of BC. BC. So it's going to go through the midpoint of BC. I got to find that first. Midpoint of BC. So add them together, divide by 2. So we'll get 6 over 2, which is just 3, and 6 over 2, which is just 3. So 3, 3. 3 and 3, right about there. And I know it's going to go through at a right angle, so I know it's going to look something like that. Right angle to BC. Oh, I got to find the slope of BC. That's step 2. So you can see our points here. BC. So I need to do negative 2 minus 8 for the y's, and 2 minus 4 for the x's, which is negative 2. Oh, sorry, negative 10 over negative 2, which is 5. That's not my slope. My slope is perpendicular to that. So I got to flip it over 1/5 and change the sign. It's got to become a negative. And step 4, let's find that equation. Negative 1/5 x plus b. The only point for sure that I know was that midpoint, which are these numbers. All right, let's fill them in. Solve for b. So 3 for y, 3 for x, and calculate. Multiply straight across. I'll bring this over to the other side. Okay, you can use your fraction button, or if you did decimals, decimals would work with this one. It's nice decimals. Common denominator. So I need a 5 and a 5 times by 5 times by 5 gives me 15. So b is 18 over 5. Our equation, y equals negative 1/5 x plus 18 over 5. Okay, now the big lesson. Lots of lines. And the complicated part's going to try to tell them apart. A median, a bisector, and an altitude. You have to be able to tell all three apart and know what we're trying to find. It helps to draw the little pictures. Yeah, a couple questions to try. It's going to take some time. It's going to take some practice. We're going to spend a couple of days looking at these lines and how we can use them, whether it's word problems, whether it's finding where they meet. But you kind of need to have the basics down before we can do that.